Whether it's prime or composite, you got to decide, is there anything that will divide into the number other than 1 and itself? So you can try to break it down, kind of do a factor tree like you've done before. What does 8 break down into? 2 and 4, and 4 can break down, but the point is that it breaks down into something besides 8 and 1. And so if it breaks down into something besides 8 and 1, then it's considered composite. What about 41? Can we break 41 down into anything? Try some numbers. Try 3. Nope. Try 7. Nope. Try 11. You try some numbers, and then you can say, well, nope. Doesn't break down anything except for 41 and 1, so it's prime. What about 2,865? We know it's divisible by what? 5. So use your calculator. What is 5, or is 2,865 divided by 5? 570. Okay, so 5 and 573. Now we have to decide, well, already we know it's not prime, right? We can break it down even farther. I believe it's 3 and something else, but it's already composite. We can keep going, but all we're asked to do is find out whether it's prime or composite. It factored into 5 and 573. Okay, number 4. Now it's asking us to do the prime factorization of each integer. So we're going to totally break it down. 600 breaks down into what? 3 and 200. 200 breaks down into 2 and 100. 100 breaks down into 2 and 50, which breaks down into 2 and 25, which breaks down into 5 and 5. So once you can't break down any of those numbers anymore, you go back and circle all of the ones, and these are all of your prime factors. And if you wanted to write 600 as a product of primes, 600 is equal to 2 to the third, because I got 3 of them, times 3 to the first power, times 5 to the second power. All right. What about a negative number? I would start out just do -1 and itself, and then start breaking the 150 down. 75 and 3, which is 25 and 3, which is 5 and 5. Whoops, you didn't catch me. Too bad. 25 and 2. 25 and 3, 5 and 5. So -150 is equal to -1 times 2 times, well, we got a circle. Circle all the little berries on the tree. Times 3 times 5 squared. Do number 6. Okay, then you'll know it's correct. Okay, down here on number 7. Now we have variables. So we don't have to worry about the x to the 5th, but let's break the 16 down. What is 16 equal to?
4.
And what does 4 break down into?
2.
So this could be written as 2 to the 4th, x to the 5th. Okay?
We have to do these ones.
Well, no, we're leading up to some more stuff. What does 72 break down into? And you might need to do a little tree over here on the side. 72, 8 and 9. 2 times 4, 2 and 2. 9 is 3 and 3. Sometimes you have to do a little tree over on the side. So you have -1 times 2 2 to the third times 3 to the second times g to the third h to the second j. That's factored down. All right, so 9 breaks down into, 200 breaks down into 2 to the third times 5 to the second. That's 8 times 25, which is 200, times w to the 6 times x to the third. 200, I did a factor tree of 200. If you did a factor tree of 200, you got the same thing. All right, number 10. What we're doing on number 10 now, and some of this you can do in your head, but we're going to have to practice for when the problems get more complicated. So you can probably tell what is the largest number that will go into 4 and 8 evenly. There's a bigger number than 2. 4. 4 goes into 4 once. 4 goes into 8 twice. It'll never be bigger than your smallest number. So you might as well see if the smaller number goes into the bigger number evenly. If it does, that's your GCF. Okay? If not, then you may need to find a factor of the smaller number. But 4 is the same as 2 to the second, and 8 is the same as 2 to the third. Okay? So which one has the smaller exponent? This one. That's going to be your GCF. What is 18? 2 times 9, which is 2 times 3 squared. What is 36?
8 times 2.
Okay. 18 times 2 is 2 times 9. So you get 2 times 2 times 3 times 3. Okay?
At 3,
Okay.
you got
3 to the second times 2 to the second. That's 4 times 9.
Oh, 3 times 3, okay.
Okay? So, let's look at the 2's. Who has the fewest number of 2's?
The first 2.
Okay? So we're going to go with that one. Then who has the fewest number of 3's? They're the same. So we'll go with that. We'll go with that amount. That is your GCF. 2 times 3 squared, which is 18. 18 goes into 18 and 36 evenly. You didn't have to do all of that to figure it out, but that's going to have to be a process we're going to use when it gets more complicated on these future problems. You knew that 18, oh, that's worse. Try number 12. So we're looking for what they have in common. Do they both have 2's? Yes. What's the fewest number of 2's either one of them have? Same. So we'll take 2 squared. We'll take that amount. And then do they both have an 11? No. Do they both have a 5? No. So we stop with that. That's our greatest common factor. 4. 4 is the biggest number that will go into 44 and 100. 2 does, but so does 4, and 4 is bigger. We're looking for the greatest common factor. Okay. The biggest number that will go into both of them evenly. What about 125 and 30? Five goes in. So what about 15? So let's break it down. 125 is the same as 5 times 25, which is the same as 5 times 5 times 5. So it's 5 to the third. 30 is 6 times 5, which is 5 times 2 times 3. So what do they have in common? They have a 5, What's the fewest number of 5s? D has a 5. Do they both have a 2? Do they both have a 3? Then there's your GCF. Look at 16. Now we have letters.
Yay. Yay.
Just to help demonstrate, I'm going to write them vertically. So this is a times b squared. This is 5 times a to the 4th times b to the 2nd. And 10 is 2 times 5 times b to the 3rd. So let's circle what they have in common. Do they all have an a? No. So a cannot be a common factor. Do they all have a 5? No. 5 cannot be a common factor. Do they all have a 2?
Yes.
No. 2 cannot be a common factor. Do they all have a b?
Yes.
What's the smallest number?
B squared.
B to the 2nd. B to the 2nd is your greatest common factor. You can't try b to the 3rd because b to the 3rd is too big. It doesn't go into those two evenly. So I kind of broke it down, and then I also kind of arranged it and organized it, so maybe it'd be a little bit easier for you to see. I put all the 2's right here, all the 3's, all the x's, all the y's, z's, 5's, and 7's. So unless they all have something in that column, it won't be a common factor. They don't all have a 7. They don't all have a 5. They don't all have a 3. They don't all have a y or a z. So they do all have 2's, and they do all have x's. So you have to find the smallest
Just be 2.
of that row and the smallest exponent on that. So no, it's just 2.
Lots of people something.
Right? Or did I miss this one?
I think you missed that.
So 2x. Because 4 won't go into which one? 4 won't go into 42 evenly. So 4 can't be a common factor. 4 doesn't go into 42 evenly.
Where'd you get the 2's?
I broke 12 down. 2 times 2 is 4. Times 3 is 12.
I did it 3 times 4.
Right, and 4 breaks down into 2 times 2.
I did it.
You didn't break down 4 all the way. On this first example, we need to remember how to distribute. 3 times 5x is 15x. 3 times negative 7 is negative 21. If you're going to distribute with variables, ab times b to the 3rd would become ab to the 4th. And then ab times a squared would become a positive a to the 3rd b. Okay, now when we go to example 1, what we're going to do is work backwards. We have to find out what the greatest common factor is of the two terms, and we're going to divide that out. We're going to kind of pull it out. So what's the greatest common factor of 7x and 3x? What do they have in common? X. Okay? So if I do a reverse of distribution, what is 7x divided by x? 7. What is 3x divided by x?
3.
Now, we should have combined like terms, but that's not, it kind of defeats the purpose of what we're trying to learn. We need to find the greatest common factor of 24x and 48. What's the largest number that goes into 24 and 48? 24. So if we take 24 and we divide it from each term, 24x divided by 24 would be x, and 48 divided by 24 would be 2. So you check yourself. Once you think you factored it right, go back and check. Go back and do the distribution that we learned a long time ago. And make sure 24 times x is 24x, and 24 times 2 is 48. And make sure that what you get is what you started with. Because this is your answer right here. This is factored. But you need to make sure that your answer is equivalent to the question. It's kind of reverse of simplify. It's the opposite. We're going to learn to factor things out. Once you think you got it, check your work. 15 times 3 is 45. F squared times f is f to the third. And then 15f squared times negative 1 is a negative 15f squared. Does that match what I started with? Yes. So I know that this is the correct answer. And I also need to make sure that 3f and 1 don't have anything in common. So if you factored them all out and you organized them, what do they have in? What's the only thing that they all have? 2. And what's the least amount of 2's available?
2.
Or the most available? 2. That one. So all you can factor out is a 2.
Answer.
6y divided by 2. Negative 12w divided by 2.
Positive 60.
And 8 divided by 2.
But
So check your distribution. Go back through and check. 2 times 3y is 6y. 2 times negative 6 is negative 12w. 2 times 4 is 8x. Did I get what I started with? Yes. So this is correct. And do these three things have anything else in common that I missed? Does 3, 6, and 4 have anything in common that I missed? No. Do they have any variables the same? No. So then I know I'm done. High five. All right, on number 6. The first thing you need to focus on are your numbers, your coefficients. 14, 42, and 49. What is the greatest common factor of 14, 42, and 49? You got to decide that first. What's the largest number that will go into all three of them evenly?
7.
7. Okay? GCF is 7. If you need to make a factor tree and go through all the little steps, do it. Most of you can see that in your head. 14 is just 7 and 2. 2 doesn't go into all of them evenly. 7 does. So 7 has to be your GCF of the numbers. Now go through and look at your letters. Do they have any letters in common? No. They don't all have a B, and they don't all have a C. So there is no letter that I can divide. There is no variable that I can divide out from every single term. So 7 is my GCF of all three terms. So if I divide a 7 out from every term, 14 divided by 7 would be 2, and b to the third. And I need to make it this way so that when I do my distribution later, when I check, I need to make sure that I get 14b to the third when I distribute. So you can kind of check yourself as you go, and check yourself at the end too. 42 divided by 7 is 6. You have a negative 6. The variables didn't change. And then 49 divided by 7, 7. So when you go back through and check with your distribution and make sure that what you got is equivalent to what you started with, and it is, and you realize that's the right answer. And the terms you have left in parentheses have nothing in common. What does 7 have in common? What's of the 6 and 12 and 30, what's the greatest common factor? 6. Do they all have an F? Do they all have a G? Yes. So that's your GCF. You'll divide that out. What about 8? Do they all have anything in common? No. Nothing in common. So this one's considered prime. What about 9? What do they have in common? They have a 2, they have an A, and they have a B. You'll divide that out from all of them.